Hey, good evening, everyone.
Good evening.
Today we're getting a chain rule, which is free form. I spent the entire class on chain rule. So I wanted to see if anybody had any questions about anything earlier. And don't worry, I know it's like, what, I gave you a night to do 3 sections now? But don't worry if like even Monday or Tuesday you still have questions on the 3-1 or 3-2 or 3-3. I'll be glad to do it at the end of class. I didn't expect everyone to knock out 3 sections one night. But the reason I do, 3-1, 3-2, 3-3, okay, that's not that bad. It's 3-4 is the chain rule, that's the key section. The last rule for differentiation. You got quotient rule, power rule, product rule. I wouldn't list constant rule because that's easy, it's just a constant in front, right? So let me do them again. Quotient rule, product rule, power rule, and then there's this chain rule, that's the key one. So we'll spend the whole class on it. But any questions? 3-1, 3-2, 3-2, any weird problem? Google? No? Any cool? Well, please feel free to ask me at the end of class. I'll make sure to leave some time. Maybe I wanted to go over something from that. Chain rule, what is this for? I think before we write it, we should just see why is it needed. Why chain rule? Why? Why is there another rule? I thought we covered everything. Why is there something called chain rule? Well, let's start out with this. Let's start out there. Y equals 3x plus 5 squared. I want you to differentiate this. Find the derivative of y. Find y prime. Differentiate y with respect to x. Find the derivative of y with respect to x. Well, you already know some ways. We don't need chain rule. What are some ways? There's 2 ways to do it. You could expand everything, right? FOIL? Good, I like that. FOIL, do power rule. That's how I would do it. I would FOIL all that out, then do power rule. What other rule could you use? Because you made 2 of those. It could be a 3x plus 5, 2x plus 5, then you could use what? Product rule. So everyone agree? We've got 2 ways to do that problem. One way would be expand it, which means FOIL it, and then just do power rule on each little part of the polynomial. Second way is, well, I could write that as 3x plus 5 times 3x plus 5 and do the product rule. True?
Mm-hmm.
So why chain rule? We don't even need it here. Here's why. There you go. That's why we need chain rule. Can you imagine how long that would take? You can expand that? Even with Pascal's triangle, that's a pain. Because that's to the 10th power, you follow me? This just gives you an idea like, oh my God, it would be ridiculous trying to expand that. Even if you did expansion of that, I mean, how many of these 3x plus 5s would you have? It would be a nightmare trying to do this by product. Because every time you'd have to do this product, and then take the product of that with this one, and then there's more to go, right? It would just be ridiculous. So, what we do is, there's a couple ways to look at this. We'll let u equal to something. There's a couple ways to write chain rule. I write it 2 ways, and you can pick the way you like. All right? I think eventually, though, it'll just become natural in what you do. It's going to be like a natural method that you use in your logic, in your thinking. But I'm going to start out, since the first time we did it. Well, what's in this parentheses? 3x plus 5? So I can think of that as u. So I'll just go off to the side. And let's go ahead and let's let u equal 3x plus 5. Okay? So now, could you tell me what that equation is really? Now you have y equal to what?
U to the 10th.
You got a ui equals u to the 10th now. You agree? All right. Y equals u to the 10th. So far, so good? But I can use this to my advantage, because what I can do is, I let u equal that thing in the parentheses, that 3x plus 5, that portion in the parentheses. Well, then I could rewrite this formula y prime as derivative of y with respect to u, all right? And then multiply by that, derivative of u with respect to x. Now I want you to look at this. So this is chain rule. Because dy du times du dx would be the same as y prime, which is what?
dy dx.
Dy dx. So this is one way to look at chain rule. Because that problem would have been nasty trying to do it by product rule or do it by expanding the thing. So I'm saying what I can do is I can always say this dy dx can equal derivative of y with respect to u multiply to derivative of u with respect to what?
X.
X. And it's called chain rule. But I eventually will write this another way, and I think a lot of you are going to prefer it the other way. I mean, just all, but that's one way to see chain rule. That's the one way it can be written. dy dx is equal to dy du times du dx, right? So all we got to do is get the derivative of y with respect to u. See, we always did dy dx, didn't we? So I'm just going to put something here. I'm going to put something here, and I'll have my answer. Well, what does this mean? Let's communicate this clearly. This says the derivative of the letter y with respect to what letter?
U.
So go over here. Where do you have y equal to an equation with the u? Here or here?
Second one.
Write this. So let's go over here. Let's see what we get. What would dy du be? That would be the derivative of the letter y with respect to u. What would that come out to be?
10.
We can do power rule, can't we? Do the power rule on that thing. 10 in front. U to the what?
9.
You're halfway done. 10 u to 9. All right, I'll put it right here. You're 10 times u to the 9. So far, so good. Amber, okay? With that? Cool, this chain rule, I'm doing like 2 pieces. And where did I start this problem? I was like, I'm just going to let u equal something. Guess what I chose? The thing with parentheses. Right? All right, so dy du is this. Now look, what's the other piece of chain rule? dy du times this guy, du dx. So let's go over here. Do we have an equation of u with respect to x anywhere?
Mm-hmm.
Hey, we wrote it right here. So can you take the derivative of u with respect to x? What would that be?
3.
Just 3? Because what's the derivative of a constant?
0.
0. I think we're done. By the way, what is 10 times 3?
30.
I think we got our answer. There's only one thing, when you write out, you find an answer. 10 times 3 is 30. Do me a favor. Don't leave your answer like that. You go, why? Didn't the original problem have what letter?
X.
X. So at the very, very, very end, if you use this technique right here, resubstitute. Because you got to have your answer in terms of what? X. What did you let u equal to at the very, very beginning? Go back and look. What did you let u equal to? You might have it somewhere on the side of your paper or something. Oh, there it is. U is what? 3x plus 5. So I'll resubstitute. Leave the 30. Put a parentheses. 3x plus what? Is everyone count that?
Mm-hmm.
Cool. That's chain rule. But I think you see a need for it, right? It's really for, here's the phrase, composite functions. Composite functions. Do you notice that's what's going on here? This was composed of 3x plus 5, right? There was this function like u to the 10th, composed of where u was this 3x plus 5. They call it composite function. One function composed of the other. One function composed of the other. And there are going to be just multiple times we're going to need this rule, right? And so that's why we'll just dedicate the entire class to just chain rule. This whole process here, that works, right? And then in that one way to think of chain rule, find the derivative of y with respect to x, dy d what? Du times du dx. Now let's say you wanted to use this on a problem that was with respect to t. What's another way you could write it? If you had to find the derivative of y with respect to t, and you wanted to use chain rule, by the way, I call it chain rule, all right? If you had to do chain rule, what would you have to do? You would just do the derivative of y with respect to what letter again?
U.
du. You'd figure that out. Then multiply to what?
Du dt.
The du dt. You can do this anytime. It might be velocity with respect to time or anything. That's chain rule. I do want to say this though. I think a lot of you are going to do this another way. So I think I got enough room up here. All right, there it was. And we saw the story. We did that over there. We did this over there. We put this in there. We said that's chain rule. Da-da-da. It was very easy. Good job. But it was a lot of what? Come on, you gotta admit, it was a lot of writing. Do you agree? For one problem. And I said you're gonna be doing chain rule all the time. So you might want to kind of shortcut all this stuff. Well, there's another way this form was written. Everyone, this is chain rule written another way. I'll put it right under here, and I'll leave it all blank. I said it's for composite functions, right?
Hmm.
Let's say if m equaled f of g. Let's say m is some function composed of what? G. Remember this from pre-cal? Yeah, I know. F composed of g. F of g. That's what's going on here. This was a function composed of another. It was composed of that 3x plus 5. All right? Then the derivative by chain rule will be f prime of g multiply g prime of x. It's called the chain. We call that the chain. So that's how you could differentiate a composite function. This is another way to do chain rule, but I think a lot of you will think this way. I think you'll do every problem in this format. You have some function composed of g. By chain rule, m will equal f prime of g times whatever g was differentiated.
Show that using the 3x plus 5.
You bet. And then I say we do a bunch more too. She's right, Ellen. She goes, definitely do it with this one. And I just have a feeling, just from teaching Calc 1, Calc 2, Calc 3 for so many years, and I watch students, I'm being honest here, Josephine, I rarely see students writing all this stuff out for one problem. This is what I see. It's quick. You'll notice why. It's not like you had to separate and do a what? Let u equals, right? Y equal this. But this makes sense, doesn't it? This does make sense. This is really what chain rule is all about. Most students do this. So I'm going to do it. Remember, this was all this right here. I don't write it, but it worked. Okay, here we go. All right, what was the original problem? Y equal what?
3x plus 5.
I think a lot of you are going to prefer this. And after we do this, I say we make up a bunch more. A bunch more. Josephine, well over an hour, go straight through and keep doing them. All right. Check this out, Emma. I'm going to start you out. If this was just an x, couldn't you just do power rule? X to the 10th. Well, that's what I want you to do. Would you please do that? Please just knock out power rule. Just treat this 3x plus 5 just like it was an x. What would happen? Where would the 10 go? I'm thinking this just as just an x.
It's in the front.
10 would go in front. This whole thing would just decrease by what?
1.
1. So I'm going to do that so far. Do you notice I left parentheses? Josephine, so far so good? All right. So 10 in front, decreased his power by 1. 10 times something to the 9. I'm going to put my g of x back in. You go, well, what did I call g in this problem? I'm going to call g that 3x plus 5. A lot of times, Josephine, g is the thing in the parentheses. Okay? So I did this, look, I hid this, thinking it's just like an x, right? 10 in front, decrease it by 1. But now what am I gonna do? I'm gonna replace and put my G back in. So what goes here? So isn't this funny? Isn't this just like power rule? Isn't this just like power rule? You have a question?
Quick question, when you keep saying G, do you mean G or do you mean G of X?
They both mean the same thing. Isn't that cool? G of X is G. Like, see this? Y is f of X. And we can call it Y, or we can call it f of X, or we can call it f. Or when we did derivatives, Josephine, we did derivatives. I could call this Y, I could also call it f of X. I can call this Y prime, but I also can call it f prime, and I also can call it f prime of X. So, to answer your question, Josephine, G is the same as G of X. So this is that right there. And everyone, what did I perform so far? So far, this is what I performed. F prime of G. So make a note of that. This is what I performed so far. I perform F prime of G. Cool? What's missing now?
Inner derivative.
And I'll be honest, a lot of times people leave answers like this. Even in Calc 2. There's something missing. Chain rule's gonna be fast, good job. That was just F prime of G. That's all we did. We did F prime, look, we took the derivative of F, just Y, right? We took the derivative of it, and then we stuck G back in. But what's missing? Chain rule, I gotta multiply the what? The chain, what's the chain?